Hey there! Today we're going to learn how to do an a priori sample size computation using GPower software. And we're going to do that using a t-test. So let's do it with an independent samples t-test, which we can find here. It's the difference between two independent means, and we will just click on that. A priori is already highlighted. What does that mean? It means the number of people that you're going to need in your sample given certain inputs. So let's talk about those inputs. Well, when you're doing an independent samples t-test, one of the first things that you're going to specify in your hypothesis is, are you looking for an inequality or are you looking for sort of a difference? And if you're looking for an inequality, then it's a two-tailed test. So let's say that you're doing a test on income as a function of gender. And your null hypothesis is that the income of men and women is the same. That is a two-tailed hypothesis structure. However, let's say that your null is that the income of men is less than or equal to the income of women, and the alternative is that the income of men is greater than the income of women. Then you're looking at a one-tailed structure. So let's just leave that 2 for now, but at least you know how to change that if you need to. Detectable effect size here, I'm showing you what the cutoffs are in GPower, and these come from Cohen. It's 0.2 for small, 0.5 for medium, 0.8 for large. Now, this just means what is the effect size that you want to be able to detect. So quite logically, if the effect size is very, very, very small, you're going to have a larger sample size recommendation, right? And on the other hand, if it's a big old effect, then you're going to need a smaller sample. So typically the default here is to just begin with medium. And if you have specific reasons to expect a smaller or larger effect size, or if there's an average effect size from previous studies that you want to type in, you can do that, just so you know what that is. Alpha error here, this is just your p-value, and typically it's just left at 0.05. Power, this is interesting. Power is the rejection of a null hypothesis that is actually false, your probability of doing that. So clearly you have an interest in having a high power. 0.95 is quite high, and it's GPower's default, but what you'll see recommended a lot of times in the literature is actually 0.8. So I'm going to go ahead and change that. And one reason for doing that is also that your recommended sample size will come in a little bit smaller. And finally, your allocation ratio is just the ratio of people in the two different groups. So if it's equal, then you would just type in 1. However, let's say that there's 40 people in one group and 20 in another. You could either type in 2, 40 divided by 20, or you could type in 0.5, 20 divided by 40. It wouldn't actually change the sample size recommendation. They would result in the same thing, but just so you know how to alter that if you want to. And then you just push calculate. And so here you can see that your recommendation is 64 people in each group for a total sample size of 128. That gives you an attained power of 0.8014, etc. And then, of course, you have your critical t-value here. And once again, if any of that changes, you can go ahead and change the inputs, and GPower will give you a different sample size recommendation.